So here's our CPU radiator installed in the top of our cabinet, going down to the heat exchanger block here. And we have fans up on top here, you saw before. I'm going to put fans down here. Now there's enough room for 140 millimeter fans in here because of the way the motherboard is set up. So there is room for 120 millimeter fan on this side, and there's not quite enough room for that big of a fan over here, but there is big enough room for a 92 millimeter fan over here. So both those will fit, but the trick is we've got to make some kind of adapter so that we can screw into the radiator, and so that the fans will stay up here properly. So I think the way these wires and stuff are in the back, like this is the CPU power wire. We're going to want to put these fans so they're all the way to this side of the radiator, which is 140 millimeters wide. And we're going to want to put them up to this like this corner and this corner. So we're going to have a plate similar to this plate, which I tried earlier, part of my failed prints before. It just goes in there like this. It screws into the radiator and then has a hole that's the same size as the fan we're trying to use. So on this side, this is a 140 millimeter hole, which we can't use. We're going to have a 120 millimeter hole so that we can screw this fan into it. Now we could do something tricky and actually, I'll think about that. We could make a bracket like this. It just has a cross piece in it that has the screws for these fans. That would leave this other part open, so maybe I'll do that. And we'll just set some kind of an adapter bracket so that we can screw these fans in securely to the bracket and have the bracket secure firmly to the radiator so the fans are not vibrating around and so forth. So I'm going to work on that design, and this is my first attempt, which was to make kind of a funnel. But there's really not enough room for this funnel in here. I guess I could have figured that out at the start, but it took having to print this out as a test to see if it would actually fit, and it doesn't fit. So I think it was something much simpler than this, and actually that'll be a lot easier to print than this thing was. Alright, so that's our next task, and as you can see, again, this is my first attempt. The invention process is not a straight line. A lot of times you go down the wrong path and you have to backtrack and figure out the best way to solve the problem. Alright, so this is the design we started out with for the 140 to or 120 to 140 adapter, and there wasn't enough room up by the radiator on top of the PC, so this was out. I did actually print this, but then it I could see it didn't fit, so probably could have figured that out ahead of time, but anyway, it's worth a try. Then here's our more radical one. This is the 92 to 140. So we didn't bother to print this one out because the other one didn't work. So there wasn't enough room for this one either. So then we switch to, let's go to the other one. We switch to this one. So I made a flat adapter. These are the screw holes for 140. And these are the screw holes for 120, and I'll show you the simplify or the OpenSCAD project for that. So here's the project I came up with. So it's just a rectangle with screw holes, and then it's got a flange for the 120 millimeter fan, and then it's got these cutouts because there's still going to be a fan on top of the radiator that's pulling air up. So I want to have as much open area as I can, but these regions right here were very thin, so I wanted to have some more support here. So it would support the 120 millimeter fan. I didn't want to flop it around, so we had to put one on the corner here and on the two sides, and also I added some little material here along this edge. Now this area here is going to act like a gasket for the fan. So because of the way the radiator is set up, there's fins under here that doesn't allow air to once it starts going through the radiator, it's not going to go sideways. So this will push air using a 120 millimeter fan through the radiator, and it'll get sucked out the other side by a 140 millimeter fan. The 140 millimeter fan will also pull some air
through the vanes that are not covered up by the this bracket. So that's this one, and then so we can get rid of this. And then here's the project for the 92 millimeter fan. So this is even more open. There's a lot more open space here. But again, this flange here, I had to reinforce it. I didn't want it just sitting out in space. And then I also put the extra material here. Now, one thing interesting is that this screw hole here is shared between the, same thing on the other one, the 120. Screw hole here is shared between the 120 millimeter, the 92 millimeter fan and the 140 millimeter radiator. So there's going to be a long screw through here that'll connect this bracket securely to the radiator. And then we use screws on the other side to hook up the fans to here. And then these will be attached to the radiator with just short screws. So again, I just created some shapes here, and I'm going to be posting this code and the code for the 140 to 120 millimeter offset fan bracket on Thingiverse, and I'll put a link to that in the description. So we come over here to Simplify 3D. What we're going to do is we're going to show our process. So we're printing PETG because that's good up to 100 degrees C, which is hopefully the radiator shouldn't get above that. So PLA starts getting soft around 60 degrees C. So definitely the CPU can get over 60 degrees C. So theoretically the radiator can get that hot too. So we want to definitely use PETGs, which means we're using higher temperatures to print it. So I have 65 degree bed temperature and a 237 degree extruder temperature. And then for cooling, first layer no fan, the second layer on I have a 10% fan. That's for my printer, that seems to work the best. And when you put a 10% fan on here, then this 237 goes down to 235, and that's what I'm printing most of this print at. Now, one thing we wanted to do was, because I want this shape here to be the edge to be super clean, I added a outline. So one of the additions, I added a skirt or brim 1 millimeter from the 1 millimeter from the main object we're printing. So if we go to prepare to print, we can see there's the outline. That's a little purple. The other thing about this printer is normally it'll put a wipe line along the front, but because we have this outline and this shape is so big, I didn't want to put the wipe line here, so I moved it over here. So I can show you real quick how I did that. So under the code, under the scripts rather, the starting script, instead of moving to the front of the printer and printing, I'm moving to the side over here. And let's see, where does that happen? Yeah, so here I move to the back left corner of the bed. So I'll put this code in the description so you can see it, so you don't have to try to read this. I left most of the commands in here this is the default script, and I decided to leave it in there so I could look at it again without trying to recover it somehow. So what I do is I start back here, then I extrude a line of filament, and then at the end I move it quickly and then lift up, and that will hopefully terminate the filament here, and then it'll go over and start doing the outline. So with the wipe move and the outline, we definitely get a nice clean start to the print. Let's go and see how the print goes. So it's 15 layers. So we've got 2 shell layers and 3 solid layers on the top and the bottom. So here's the 2 shell layers on these openings, and then you've got this little cross hatching in between. So this is enough room here to get a strong joint here. Could be slightly bigger, but it seems to be okay now that when I printed it out, it came out okay. So then once we get beyond 3 layers, then we start doing 50% infill. It just makes it a lot stiffer. Uses more material, but I just found 50% infill for something you care about the strength of just works the best for me. It speeds it up. You don't want to do solid infill because it takes too long and uses too much filament, but 50% is good. And you see it does the holes and the outlines. So, all right, so let's take a look at the other one. So here's the OpenSCAD project again, and here is the Simplify 3D version. It's got the same process as the other one. All these settings are the same, including all the scripts and everything. So we print, we see we do the white move over here, and then we do the outline, which is the purple. And this prints 15 layers again, just like the other one, just it's different shapes. All right, so we print these out, and I would say 98% sure it's going to fit this time. And then we'll be able to improve our performance of our CPU cooler. That's the whole point of this exercise. All right, looks like our print came out perfectly.
This is a much simpler print than the other one I was trying to make, so I expected this to work. Got good bed adhesion, not too much, but solid. So we don't have any curled corners or anything. One string left, that's pretty typical of PTG. The last little thing sticks to it, but it's a nice clean print. And here's our fan. So our fan is going to go like, let's see, like this. Yeah, so the fan's going to go on here. And then these other screw holes are for the radiator. So we'll screw the fan in from this side. Actually, we're going to put, now that I think about it, well, we could put one screw through here all the way into the radiator. The rest of these will have to be the inverse ones that come in through the back. So that should work. And now we just need to print the smaller one, the one with the smaller opening for our 92mm fan. So that's next. So far, so good. All right, another successful print. Last string off. Looks like it came out just as I wanted it. So bed adhesion is perfect. Sticking just as much as it needs to, not more. I wasn't quite as aggressive at squishing it down this time, and it still worked fine. So. I did an outline. Let's see if it'll come off. Yeah, so this outlines sometimes sticks really hard to the print bed, but if you ramp the print bed up to 120 degrees, it'll come out. So get that started while I work on this. 115. Okay, so we're not going to print any more of this PETG right now, so we have some other stuff to do to switch back to PLA, like clean out the print head with this clean filament. So even though we're ramping this up to 115, by the time we're done cleaning, it'll be back down to what it needs to be, 45 for the PLA. So in any case, let's check this out. We'll take it over to the bench and see how it fits with the smaller fan.
If you like this video, please give it a thumbs up. Post a comment if you have any questions or ideas, and I'll try to respond. That's all for now, but more videos are coming, and if you want to see them, please subscribe to my channel and turn on the notification icon if you don't want to miss one. This is Beta Cygni signing out, and keep looking up.